Hi friend, welcome to PLANTI.com. Today I am going to demonstrate about second part of video amino acid in biochemistry. Optical property of amino acid. The term optical means light property of amino acid. That means what will be effect when a light passes through amino acid? A tetrahedral carbon atom with 4 different constituents are said to be chiral. In previous video, I say about what is chiral. A carbon that have 4 different hand. 4 different atom present in its 4 hand. That's chiral. All amino acids except glycine are optically active. Except glycine. Why except glycine? Because glycine have 4 alpha carbon have 4 atom. 1 hydrogen, 1 COOH and 1 NH2, and other hand the R group also H. Here 2 atoms are same, hydrogen, so it is not chiral because chiral have 4 different atom in its 4 hand, but here not, two atom are same. Glycine are optically active. When a plane polarized, optically non-active, not optically active. When a plane polarized light passes through a solution containing a single chiral compound, the chiral compound causes the plane of vibration to rotation. That means it's a sodium lamp. It is passes through monochromator filter. This sodium lamp light, it is not polarized light, it is unpolarized light. When this unpolarized light passes through polarizing filter, it's have same direction, polarized light, same direction. And when this light passes through a sample cell, here present a amino acid sample, this light passes through this amino acid sample, then we see the changes means rotation. It will be left side rotation, it should be right side rotation. And what is rotation difference occurs? This is a detector, detect this. The whole process are measured by polarimeter. So here I show that a unpolarized light passes through a polarized filter, and this polarized light passes through a sample and a analytic filter that present, and this a detector present that's measure what rotation will be occur. Optical activity is measured by polarimeter. The magnitude of optical rotation indicates the extent to which plane of linearly polarized light is rotated. Optical activity measured by polarimeter, I said previously, the magnitude of that means which plane linearly polarized light rotate. That means this magnitude can, here it can be say what direction it will be rotate. Sign represents the direction of rotation. This sign here you see that this in this side plus sign and in this side minus sign. This sign can say that what will be rotation. It right side rotation or left side rotation. Optically active compounds that rotate the plane polarized light clockwise are said to be dextrorotatory, small d here, not capital D, and plus sign. That this is dextrorotatory. This plus sign here, this direction, here this direction are plus sign and dextrorotatory, small d, and this direction minus L, left side, this is levorotatory. Optically active compounds that rotate the plane polarized light counterclockwise, that will be levorotatory. Enantiomer. This term enantiomer will have to reflect your mind. It's want to say about mirror image. Here an amino acid with a chiral carbon. Here also you need a chiral carbon, not glycine. Exit 2 configuration that are not superimposable mirror image of each other. These two configurations are called enantiomer. Enantiomer two types. It should be DL configuration and RS configuration. When the hydroxyl group is on left, the configuration, here hydroxyl group in left, this is L enantiomer, and when hydroxyl group is on the right side, this configuration D configuration. Hydroxyl group OH present here left side and here in right side, so it is D and this is L. Here we see that here suppose a mirror present here, then it is opposite to it. This is mirror image. When I put a mirror here, we see the opposite image. This is enantiomer and DL configuration. RS configuration. RS configuration seems like DL configuration, but here difference. Why difference is from DL configuration? Because DL configuration you say that in the presence of OH group which side present, and here R configuration has its relative direction of the priority order clockwise direction. That means here you have to count in the atomic number. Here we see that here hydrogen here and chlorine and carbon and oxygen, four different atom present: chlorine, hydrogen, here oxygen and here carbon. We have to know the atomic number. Here we see that higher atomic number chlorine 17, oxygen 8, carbon 6 and hydrogen 1. So higher which one? Chlorine 1, 2, oxygen 3, carbon and 4 hydrogen. So here 1 chlorine, here also see that 1 chlorine, second oxygen, third carbon, fourth hydrogen. So 1 chlorine, then it is present here 1 to 2, 3, 4. That's it is clockwise. So it is clockwise, that's why it is R configuration, because I say it clockwise direction is priority order R configuration. And this L here also measured the same way. Chlorine 1 number, oxygen 2, carbon 3. We have to say 1 here 4 present, but you have to know think about 1 to 4. That's not 1 to 2. You have to go through 1 to 2. 1 to 2. Here this is counterclockwise and this is laboratory, not, it is S configuration, seems like laboratory. Absorbance of UV ray by amino acid. Total 3 amino acid can absorb UV ray. These 3 are also aromatic amino acids. Aromatic amino acids, 3 present: tryptophan, tyrosine and phenylalanine. What I say that single letter code of these 3 amino acids? One is W, one is Y and one is F. Phenylalanine, F. Tryptophan, W. Tyrosine, Y. I said that previously. Here aromatic amino acid. Here this graph represents that tryptophan, the red one tryptophan, and the blue one tyrosine, and the black one phenylalanine. Tryptophan is highly used for that measured in polarimeter. The sample, in case the polarized light passes through it, this are tryptophan 279.8 nanometer. This is a name, small a name. This present absorbance at 280 nanometer is used for detection and quantification of purified protein. The absorbance H protein depends on the number and position of its aromatic amino acid residues. Next, amino acid can act as acids and base. Amino acid can either donate or accept a proton. Therefore, amino acids are amphoteric in nature. It can donate, it can accept. At low pH, when low pH, carboxyl group accept a proton and become uncharged. So overall charge is positive. That means here you see that here carboxyl group, this is low pH condition. That means it is acidic medium. Here carboxyl group accept proton and it become uncharged. Here no charge present here, not positive, not negative. That's why this is positive charge here. NH3 here positive because it's donate proton and it become positive. So in the low pH carboxyl group accept proton and become uncharged, and in the other case at high pH amino group loses its proton and become uncharged and overall charge is negative. And when high pH occur, high pH here high pH, when high pH the carboxyl group donate proton and amino group accept it donate and it become negatively charged and it is uncharged. So overall charged here negative. Here this is uncharged, no charged. This is positive charged. So count here. This is positive charged. This is negative. This is for no charge. Here count. This is negative charge. Same case. When overall electric charge is 0, that specific value of pH called isoelectric point. Overall electric charge when 0, COO minus NH3 plus. Here negative, here positive. So net charge 0, here net charge positive, here net charge 0, here net charge negative. This portion when net charge is 0, it's called isoelectric point. What is isoelectric point? You know here, when acidic medium to isoelectric point occur, it's called pKa1. And when isoelectric point to basic medium, it convert it pK2. pK1, pK2. Hope this video is useful for you. Thank you for watching.